Now, parallelogram. On by vectors B and W. Area is the base times the altitude. So I'm going to get my parallelogram here and reconstruct it into a rectangle. We'll take this as the base. We could have taken this as the base. Or this is well, this is a little more confusing. Here's your base, here's your altitude. Now, if I think, well, if I stand here, and here with a right angle, I get a triangle. If I take this triangle, put it over here, I've now got a rectangle. Here's the base, and here is the altitude all the way across. We know what the area of a rectangle is. It's the number of units of the base multiplied by the number of units in the altitude, simply because whatever your altitude is, whatever your base is, that's how many blocks you got. Every row here is as many blocks as the base, and you got as many rows as you have altitude. So that's something you should understand at the most fundamental level, even though it's never really taught that way in a way that sticks in the secondary schools, or it starts in middle school with the areas of rectangles, with even before middle school. And the third grader can understand the area of a rectangle if it's a whole number of units, a whole number of units. You get into fractional units and stuff, but I need to do that if you go fraction. Anyhow, there it is. Okay. Now, what's that have to do with all that orbital calculus? Well, okay. Magnitude of your cos phi. Right? If you take this to be your altitude, then you've got this triangle here. Okay, well, that triangle is a magnitude of v times the sine of theta. Again, if you don't know how to look at the triangle and instantly see if that's what you get when you multiply this by the sine of this angle, keep looking. Okay? Look a lot. Get used to it so you don't have to stumble over it later. And I think maybe you do, but just make sure you understand that. And of course, make sure you can go back to the definition to make sure you get it right. But make it automatic. Okay. Well, so what we have is now this parallelogram. Change the magnitude of W, altitude is magnitude of z sine theta. So you multiply those two, you got this, which is magnitude of the product. And again, if you don't, where's norm sign? Okay. If you don't understand this at this level, then you're just doing the formula. fairly easy to remember that the area of parallelogram exists, but how are you going to be sure if you don't know these fundamental facts? Okay. An engineer, you're using that formula. How are you going to be sure of it? Well, you can take an instant and think. If you really understood it, you just put it together and say, yep, that's right. I can move on. Okay. I know that's going to be right. As an engineer, you're probably going to be using software to do all this. You got to know software. Okay. And whether you actually have to know this to do the engineering, you're going to have to know other things at the same level. You're going to have to get to this level to put all your understanding together to give yourself a constellation of concepts and techniques that allow you to solve difficult problems and work out difficult things with confidence. The confidence comes from knowing the basic things. Okay, well, now let's go to three-dimensional. So we're going to have V and W down here. We're going to have a parallelogram. And then we're going to have a U. And let's let U be this. And now we're going to be able to do a three-dimensional parallelogram. Well, it's not a three-dimensional parallelogram, but we take this into three dimensions. Pleasure a little bit of some of the sketching. You can see what we got. Kind of wireframe diagram of a three-dimensional solid. And we got V cross W out there somewhere. So let's say that here is V cross W. Okay. Now, an altitude has to be in a direction perpendicular to the base. And the altitude perpendicular to the base is the projection on the V cross W of the vector U. In other words, U here, whatever the orientation of these things is, project over here at a right angle. And that gives you the altitude. Okay. And that projection equals U dot V plus W by the magnitude of V cross W okay. So your volume is the area of the base, which is magnitude of V cross W multiplied by this projection. So the volume is the area base times the altitude okay. And if you, now, altitude, syllable in there. So if you put this together with this, you get the volume. And it involves U dot V of L. Okay. And the altitude is actually the magnitude of this. Using that. This. Well, the base is magnitude of V cross W, right? The magnitude of all this, well, it's the magnitude of this times the magnitude of V cross W over V cross W. Do the magnitude of all this, you get the magnitude of V cross W here. You get a V cross W here, and now you get two V cross W's in the denominator, they go away, and this is all you left. I'm going to leave it to you to put that together. But here's your picture. You have a picture of, first of all, you have an understanding of what altitude base means and why the area of a parallelogram is the altitude times the base. Here we see that the altitude is magnitude of V sine theta for this parallelogram, and the base is magnitude of W. So right there, we confirm that V cross magnitude of V cross W is the area of the base now of this parallelepiped. Whatever U is, most likely not perpendicular to the base. You got to get the component of U perpendicular to the base, that's your altitude. Once you've got that, you just write things out, think about what they mean, understand the projection, and you're home free. Then you understand why you have this product. And you also have an important geometrical picture